Yes, class, am I audible to all of you? Humam, Austin, Tarif.
Yes.
All right. So in the last class, we had started with power, right? This derivation we had completed, and we reached to the conclusion that the formula of power is ERMS multiplied to IRMS into cos phi, where cos phi is what? Phi is basically the phase difference, right? The phase difference that occurs between current and voltage, whatever is given depending upon the device. Now, ERMS, you can further write it as E naught by root 2. IRMS, you can further write it as I naught by root 2. We didn't discuss power factor. We didn't discuss wattless current. These terms are left. See, wattless current basically means the alternating current which is obtained when average power through the AC circuit is 0. See, when it says average power through the AC circuit is 0, this average is 0. This average becomes 0. ERMS, IRMS, cos phi. So somehow you will have the value of phi as 90 degree. So it will be equal to 0 because cos 90 degree will become 0. So in any case, if you are getting the values of power as 0, this value of power, then you will say this is the current that is flowing in your circuit. A term is given to it, that is wattless current. That is it about wattless current. What you have to remember is that cos phi will be in such a manner that you will have P as 0. Power has to come out to be 0. Now, what is meant by power factor? Power factor means this cos phi. This cos phi is what we call as power factor. So you will be having circuits, you will be having questions where you will be asked what calculate the power factor of the circuit. So power factor basically means cos phi. Instead of constantly referring it to as cos theta, cos and phase angle between them, we just have a specific term for it, that is power factor. And this formula we have already done, which is resistance divided by impedance, R by Z. The same formula you will be using here, R by Z. This same formula. All right. So cos phi is equal to R by Z. You will use this. Remember, we had done earlier also cos phi is equal to R by Z. Tan phi also we did. So this is same. This is similar to what we have done. So cos phi will remain the same. And yes, one more definition that we discussed was wattless current. Now, current, if we talk about the energy through an inductor. So inductance is L. So energy through the inductor becomes half Li square. And if you people, can anyone tell me what was the energy through capacitor? What was the energy through capacitor? Yes, voltage is V, capacitance is C. So what is the value of energy? Formula of energy for a capacitor. Yes, Pfizer. Energy of a parallel plate capacitor. We have derived this also. Austin?
Half CV square.
Yes, someone answered. Tarif answered, no?
Yes, miss.
See, half CV square, you can use half Q square by C, you can use half QV, you can use any of these you can use. So half CV square, you can use half CV square. So for when we are talking about inductor, so formula of energy is half Li square. All right, half Li square. And when we are talking about the energy across a capacitor, so that is half Q square by C, or that is half CV square. Now, there is a question where we have to prove this part, prove wattless current, prove that average power is 0. That I'll discuss later. But just note down all these points, then I'll discuss. Because that's a derivation which comes. Now see, when you have to prove that average power is zero, you can prove it using capacitor also, you can prove it using inductor also. All right. Now see, we'll prove it using capacitor. Only one device we'll prove, the other is similar. But how? See, here when we're talking about capacitor, E is equal to E naught sine omega t. And when we are talking about current, current is I naught sine omega t plus pi by 2, right? Which is equal to I naught cos omega t. This is just reverse when we are talking about inductors, right? When we're talking about inductor, this is just opposite to it. So that's why the entire proof will come out to be the same. You just have to focus here on how to go by the steps. Otherwise, the proof is same. Now, see, uh, we'll start with work done first. What is work done? Power into time. See, formula of power is what? Work done per unit time. In class 11, you people must have studied. So work done is power multiplied by time. Why are we bringing in power? Because we have to prove average power is zero. So that's why interference of power we are getting. Otherwise, to prove or otherwise the rest of the questions of for energy will be solved normally the way we have been performing. Anyways, dW is equal to P dt. All right. Now see. Further, see, remember I told you P is equal to VI. P is equal to VI. So this becomes EI dt. So what is dW equal to? dW is equal to EI dt. That is our equation. Now, what is the value of E? What is the value of I? We already have it with us. So E is equal to E naught sine omega t. I is equal to I naught cos omega t. dW, this is E naught sine omega t. I naught cos omega t. I'm not writing sine plus pi by 2 or sine minus pi by 2 because ultimately you'll have to write it as cos theta only. So for that, I'm writing it as I naught cos theta. Now, integration of dW. We'll integrate this entire term. So this becomes, and yes, one more thing, class. See, for solving this question, no, we will multiply and divide it by 2. All right, we'll multiply the numerator and divide it by 2. Why? See, I can write E naught, I naught by 2 together. And what else can I write? Sine this 2 omega t dt. This is an identity, no? 2 sine omega t cos omega t. This is equal to sine 2 omega t. I have mentioned this identity before. So those who do not remember, just turn the pages and see. So this identity, to make this identity applicable, we have intentionally multiplied and divided 2. Fine. So this is how I'm going very slow. Please, wherever you're getting stuck, let me know. These steps are fixed for inductors as well. Fine. Fine. So dW is equal to EI dt. Multiply 2, put the value of E and I. E was I naught by omega t. I was I naught cos omega t. You have these values with you. Fine. Till here, you have obtained the value. And why have we multiplied intentionally to make this identity? Now, what is power? Power is actually work done per unit time. We want to find out power only. We want to find out power first. So power is work done per unit time. So this is our work done, no? So this means when you are integrating it, you will have time also in your calculations, 1 by t, and then this integral from 0 to t, wherever you are calculating. Clear? 1 by t. dw over dt over t I'm writing, that is the total time. What you can do, you can write it like this also, integral of d omega over dt. So d integration of dt will in any ways become t. So that's why I've written 1 by t already. See, what did we do? Work done we calculated. We have not actually calculated. The calculation part is left. Work done we have obtained. Work done you divide it by time, you get power. Now, whatever calculations we'll be performing, that will give you the values of work done, power. All right. Earlier we were calculating work done. Now, see, let's put in the values. 1 by t is there. So average power will become 1 by t. E naught, I naught by 2 is also constant. So I'm also keeping that aside. Yahin se. ठीक है, because rest of the integration we have to perform. Integrating it sine to omega t dt from 0 to 2. So this becomes E naught I naught divided by 2t. This is a very important derivation. That's why please mark this also. Just put an asterisk sign wherever you are performing calculation. So this becomes cos 2 omega t divided by 2 omega. This step also I have told you how to write all these steps, integrating it from 0 to t. Clear? Average value of power we have kept. Now this is till here you have to apply mainly this step, you have to apply all the physics which you are studying. Now what you have to do, you just have to perform the calculations. But look here, this becomes minus E naught I naught by 2t. You have cos 2 omega is 2 pi by t into t minus you have cos 0 degree. So tt will be cancelled. This becomes minus E naught I naught by 2t. Wait. 2t. This becomes cos 4 pi minus cos 0 degree. See, cos 4 pi is also 1 minus E naught I naught by 2t. This is 1 and cos 0 degree is also 1. So they'll cancel each other. Finally, value of P average, we'll have it as C. This was the derivation which you have to remember. See, I'll repeat the steps again. This is an important derivation class and I have seen it coming a lot. In your previous year's questions, if you will see, average power has come. In your 1 marker questions also it can come where you have to choose 0 value. So do not waste your time doing calculation. Just do the calculations, direct answer. Firstly, we have written the value of E and I. We have calculated the work done's formula. Work done is power into time. So value of power we have kept, E I dt we have obtained. This step we have reached. Then we already had the value of E and I in terms of sine and cosine that we have kept. In order to make this identity and solve our question further, we have multiplied and divided it by 2. Then this is what is work done. Now, in order to obtain power, because ultimately we have to obtain power, we have divided work done with time. Once time work done is divided by time, we have then integrated it and final answer comes out to be C. That's it, what you have to remember. Note it down. I hope by now it is clear. I have repeated it multiple times. This is clear to all of you. Alia, Austin, Faiza, Humam, Tarif, clear?
Yes, ma'am.
Yes, miss.
Okay, note it down. Now, see class, this question. This says that a light bulb is rated at 100 watt for a 220 volt supply. You have to find out peak voltage of source, resistance of the bulb, and RMS current through the bulb. See, for the first part, E naught by root 2 is equal to ERMS. Find this relation I have told you earlier also. This is very helpful. So E naught will be what ERMS is already given to us, that is 220 volt. E naught will be 220 root 2. That's it. This much volt. This is the answer of the first part. Coming to second part was power, no? No, resistance. But see, power is already given 100 watt. Power is already given as 100 watt. ERMS is given as 220 volt. You have to find out resistance. You will use, if you remember in current electricity, we did this formula, P is equal to V square by R. So just convert, instead of V, write ERMS. Understood? So formula for you, this will become P is equal to ERMS square by R. Fine. So we have to find out R. So resistance will be equal to ERMS square divided by power. So this becomes resistance is 220 into 220 divided by, okay, this is 100. 0 will get cancelled. That so you have 22 square, so that is 484 ohms. Third part says IRMS. See, you have ERMS, you have resistance. IRMS is not a difficult task to find out. IRMS is ERMS by R. ERMS is 220, resistance is 484 amperes. Please just check this answer, whatever it's coming. And yes, LC oscillations which you're seeing, that we are not going to do. LC oscillations is not a part of your syllabus. That has been deleted. So LC oscillations we are not going to do. Now we just have to deal with AC transformers. Fine, write this question, then we'll start with AC transformers. See class, now the concept of transformers. So transformer is basically a device. You are having voltages, two types of voltages will be there in your circuit. One will be high voltage, one will be low voltage. So if you have to convert high voltages to low voltages or low voltages to high voltages, that is done by transformer. So transformer is not a very different device whose mechanics you have to study. Just two coilings, mutual induction is occurring. Induction, EMI, same topic. In some books, you will find AC included in the topic of EMI already. All right, because of mutual induction, but we are doing it here because of alternating current. Now, transformers are also of two types. You have step up transformers and step down transformers. So if you are converting the voltage from low voltage to a high voltage, all right, low voltage to a high voltage, then that transformer you call as step up transformer. So understood, transformer is which type of device? It creates alternating current. AC is being produced, but by converting high voltage to low or low voltage to high. So if it is converting low to high, you call it as step up transformer. If it is converting high voltages to low, you call it as step down transformer. So what is the principle of it? It is basically based on mutual induction. Now, two types of transformers exist. One you have core type, one you have shell type. In core type, what we have concentric ring in the form of circle also, mostly it's in the form of a rectangle. All right. Now, you take one coil at one end, you take another coil at one end. So mutual induction will occur. This type is known as this type of transformer is known as core type. So one will be primary, which will be inducing. Second will be secondary, which will be induced. So mutual induction, two coils are produced. One is that, now see, in core type, there is a proper separation between them. In shell type, both are overlapped to each other. Now mutual induction will be occurring within the wires like this. They are actually in contact with each other. Their mutual induction will occur. Fine. In mostly the most common types are core type, but shell types are also present. So you should be aware of shell type. This I'll discuss first. Okay, let me discuss this. This formula you people already remember. That's why this is not difficult. You already know the whole concept of mutual induction. E is equal to d phi over dt. Remember, we did Faraday's law. EMF is directly proportional to rate of change of flux. Remember? So if one turn is there, that is E is equal to d phi over dt. All right. N number of turns are there. So E is equal to N d phi over dt. All right. And E is equal to N d phi over dt. This we have done already. So similarly for the primary coil, we will write voltage primary, number of turns primary. So this becomes EP is equal to minus NP d phi over dt. For the secondary coil, this becomes ES is equal to minus NS d phi over dt. This you have to remember. All right, now see, let's come to the working of it. It says that as the alternating current flows through the primary, just a revision of mutual induction, that's it. As the alternating current AC flows through primary, it generates magnetic flux. Remember, change in magnetic flux, change in magnetic field lines will produce change in magnetic flux. And now this change in magnetic flux will pass through the secondary coil. So primary coil is there, secondary coil. Now, due to the change in the magnetic flux, we have studied that whenever there's a magnetic flux change in our circuit, EMF will be induced. Why? Because of the cause that is producing it, right? And it opposes also according to Lenz's law. So induced EMF will occur in the second. Here magnetic flux is changing. Here the EMF is being induced. That is what is meant by magnetic flux. So induced EMF will occur in the second. Now, self-induced EMF will be there in the primary coil as well. Yes, self-induced, we have studied self-induction. So within the primary coil, self-induction will also be there. But right now, we don't have to focus so much on induction part. See, when we take the ratio of EP volt, this EP is equal to d phi over dt and ES is equal to NS d phi over dt. If you take the ratio, d phi over dt will be cancelled. So you will be left with this relation EP by NP is equal to ES by NS. This relation you will be left with. EP by ES is equal to NS by NP. Now remember, how to remember this, because class this becomes confusing when we are talking about this becomes confusing in the sense, see, you can remember it like this. If in the numerator you have primary, तो primary होगा. If you have secondary in the numerator, then it will be secondary. Like if I write it as ES over EP, so this will become NS over NP. Do one thing, note it down till here. So secondary together, primary together. Do not cross it, otherwise your entire numericals will just go in vain. Note it down till here. I'll discuss some more things. Note it down. C class. Now, when we talk about power, so power in the primary will be EP into IP, and power in the secondary will be ES into IS. Now, class, when you will use this relation, uh, P is equal to VI. Based on this, we have written this. All right. Now, when we're talking about current, so current will be opposite. I have told you, no, ES by EP will be equal to NS by NP. Current will be opposite because see, if you take their ratios, resistance will be the same. P is equal, if we go by Ohm's law. What is Ohm's law? Ohm's law says that V is equal to IR. So when we talk about V is equal to IR, or from this relation, let's not go into Ohm's law because here again resistance will come. Even if we just consider this relation, P is equal to VI. If our power remain constant, then I and V are inversely proportional, right? So that's why the relation that you have over here is EP by ES is equal to NP by NS. Still here it's clear? PP, primary. But when it comes to current, current will be opposite, ES by EP. That's it. This formula is sufficient for solving all the questions. One question we have to discuss. This we'll discuss right now only. So power is this. Input power means the power of the primary one. Power of the primary one, this one. And this is outwards, power of the secondary one. Coefficiency of transformer is output power, means that has been generated divided by input that has come from the primary into 100 to get it in the percentage form. That is known as efficiency of transformer. One question, let us see, based upon this, all the parts will help in coverage of all the formula. Quickly write down all these formula. One question we'll see. Class, we'll write down the solution of this question tomorrow. Time is not left. Tomorrow, let's complete this question. This is the last question. We'll start with EM waves tomorrow. Okay, class. Thank you so much.